Good afternoon. Everyone have a good lunch? So my name is Jim Hogg. I am a program manager in the C++ compiler team. I'm based over on the main campus for Microsoft in Redmond, which is near Seattle. What I'm going to talk about over the course of the next hour is application life management tools, concentrating especially on the specifics for C++. And this will be for the next release of Visual Studio. I shall talk slowly as I go. As you maybe can tell from my accent, originally I come from Scotland, but I've lived and worked in the US now for 12 years. So my accent is half American, half Scottish. So as I go, I shall try and talk slowly. And if there's anything that I say that you don't understand, or if I use abbreviations that I've not spelt out, just stop me and ask. The audience is small enough that we can be more interactive than usual. So here's what I'll do for the agenda. A little bit on the background of Application Life Management, or ALM for short. And then specifically ALM features that apply to C++. Most of the time I shall spend running demos, typing in live code. So we'll look at, first of all, static code analysis. Static means done at compile time rather than at run time. Code understanding. Then the new feature for unit test and code coverage. Code coverage was there before, but we've changed the UI slightly. And finish up with questions and answers. So this is a slide that kind of tries to summarize the architecture for ALM, Application Life Management. And can I just check amongst the audience, who would say they're developers? Yeah, using C++? Using C#? Using Java? Using Python? No. Just one. Ruby? Okay. Anyone that works as a tester, writing test software? Oh, good. Cool. Any project managers? People that run projects rather than do them, sort of. Okay, so a fair spread. So I'll ask more questions. In terms of the projects that you work on, some projects are small. The ideal being one person. That's the best project you can ever have, right? Because you control everything. So small, like a few people, and bigger. In terms of project size, up to 5 people. 5 people on a project. Yeah, some. Don't be shy. That's the best sort of project to work on. Up to 20, 50, 100. No. 500. So, the folks that work on either small projects or medium-sized projects, ALM is what, in fact, you probably do every day. And rather than try and tie it to that diagram, which is a bit marketing or a bit abstract, I'll describe it as a day in the life of a typical developer or tester. So you come into work, you check your email, you log on and look at either the task list for features that you're going to work on today, or the bug list for bugs that you need to go fix today. Having found out what you're going to do, in case you forgot from the previous day, you then open up Visual Studio. You check out the files that are required from a source DB of some sort, you know, a version control system. You then use Visual Studio all day long in the editor and the debugger. You write some unit tests, hopefully. Right? When you feel that the software is debugged and does what you want it to do, you'll then run the build system to make sure that it works okay, and also that it does not break previous tests, the regression suite of tests that you'd built up. When everything looks good, you'll have a code review with your partner developers, yeah? And then you'll check it informally to the system. So that's a typical day in the life of a developer, from what I remember. All of these steps there can either be done manually using bits of paper for a small project, which again is super if you can do that. For a larger project, you want some help from the computer system. An ALM is a description of a system that does that help for you. So the day in the life of a developer, similar to that in the day of a life of a tester, except a tester spans more widely and sometimes does black box testing as opposed to white box. So a tester is concerned with both functional correctness, stress testing, regression suites to make sure that nothing broke, and performance, right? Both throughput and execution speed, responsiveness. All of that stuff, which the developer usually is not heavily involved in, the tester worries about. Going now to project managers who run the project. What do project managers worry about? Well, they have a different view on the project than the actual code that the developer is concerned with. They worry about things like, okay, we've got maybe 300 tasks to be done before now and the completion of the project. How far through are we on each task? And a project manager can check that with an automated system like this by asking for reports on all the tasks. And a developer, as he goes, will update individual tasks to say, well, I estimated, let's say, 5 days for that task last week. I have now completed 2 days, so there should be 3 days left. But usually it turns out harder than I thought. So instead of there being 3 days left, I'll bump that to be 4 days. So a project manager wants to pull off reports that say, well, here's the projects, the number of tasks left, and plot the rate at which the project is completing. And if you predict ahead on that line, will it be finished on time? Also, a project manager worries about bugs. So as the developer writes his code and injects a few bugs by accident, so the testers find these bugs and log bugs against them. Again, you want a tracking system that allows you to keep the repro case, the reproduction case for the bug, to track it by number, track it by who it's assigned to, etc. And the project manager, for their part, is worried about the incoming rate of bugs being found, the rate at which they're being resolved, the rate at which they're being closed. And again, plot the graph that shows the bug glide path, you might call it, an analogy with an aircraft coming into land. Is that glide path trending down at the right angle to complete the project on time? All of that stuff is lots and lots of what you might call paperwork, but you want a system that helps you along with it, especially for pulling off automatic reports. So normally you can have reports that you run every day or maybe every 5 hours, or reports that are run by exception. So for example, if tests find that performance on a particular test suite has regressed by more than 5% since yesterday, an exception report will be popped up and sent to the project manager. All of that stuff, which is an awful lot of tracking, can be helped along by a system that does ALM. And the one from Microsoft uses at its heart the system called Team Foundation Server, TFS. Can I ask how many people use that system already in their work? Quite a few. So other folks that work on projects, do you use a project tracking system already? You do? But not TFS, something else? Yeah. Okay, so that's basically what ALM is about. And it covers requirements management, that I missed out there, but crucially important. Has anyone worked on a project that forgot a crucial requirement until you reached the very end of the project and realized that there was something missing? Yeah, me. So requirements analysis is crucially important. The project management that I mentioned, version control is just so basic. Every project should have that. A system that keeps track of individual versions of individual files, allows you to trace back all the changes that have been made, make branches so that you can work in parallel, do automatic backup, for example, of all the documents and information in the versioning system, etc. So that is ALM, and it's what you need and perhaps already use, or perhaps are thinking about using for running your software projects. Any questions at that point? So I'll list down the left-hand side there the new features in the next release of Visual Studio concerning ALM. I'm not going to go through these in detail. I'll just let you scan down the list. It covers yet more stuff that you require as part of running a big project. Maybe as background, so in Microsoft, I work in the division called Developer Division. It has a total of about 3,500 engineers. And we use TFS every day, every hour, to track hundreds of projects. And we make use of almost all of these features. So, you know, if you're running big projects, you need to take it seriously. ALM can help you an awful lot. On the right-hand side, we've got some features specifically good for C++. And the first one I'm going to talk about in red there is dependency diagrams and Architecture Explorer. And the next one about unit test framework. So all the time that I'm talking about C++, I mean native C++. The one that's been around for a while, which takes code and compiles it down to machine code that runs on raw hardware. I'm not talking about C++ CLI, the version that also targets the Common Language Runtime, the .NET runtime. So just talking about native C++ compiler. Right. So let's open up a project. As you can see on the left-hand side, can folks read that? Probably not. There we go. We've got a solution on the left-hand side with just one project called Photo Browser. And if I click on the source files, it has a few, as we can see. So imagine you're a developer, you've joined a new team, and your boss has met you, said, welcome to the new team, here's what I want you to do. We've got our little project called the Photo Viewer. Can you have a look at that, play around, see what it does, see if you can find any mistakes or errors with it, come up with a view of what extra features it should have. So what do? Well, here I've opened up the solution. Let me just click on one of the files. I'll blow that up so it's visible, 150%. Can you see that okay? Yeah. So the first thing to do with this is, well, let's try and build it and run it. See if it builds first of all. So up we go there, build solution. That was fast. So down the bottom, you maybe can't see that. It said 0 succeeded, which sounds worrying, but then it's 0 failed, 1 is already up to date. That's why it was so fast. So that's good. No warnings, no errors. Looks like a good program. Next, let's go to debug and say start debugging. Okay, so that's the application. That's what we're going to be playing with. That's what I'm going to be investigating as the new employee, the new dev in this team, to find out what it does. So on the left-hand side, it says from folder. Let's try the from folder button first of all. and it's asking me for a folder to import some data from. Now, it's called Photo Viewer, this application, so I guess it wants some JPEG files. So I've carefully placed some on my hard disk. ALM. There's a folder called Dogs. We'll select that folder. And we find some dogs. So what can we do now with this photo viewer? Let's try double-clicking. Oh, okay, it blows it up. So I've got some dogs. Moving along the top, let's try next. A big dog, another dog, a little dog, a spotty dog. Somebody described this, it's half dog, half tiger. Somebody described this at the presentation the other day as a Photoshop dog. So what else can I do? I can move it around, can move it back. Okay, so I've got the basic idea of what this application does. So let's just close this down and start to think how I can find out more about this application. I've got a runtime failure. This is always bad in a demonstration. Always, this is the moment when the presenter usually panics. But this one's intentional. This application has crashed when I closed it down. So let me just tidy this away by hit the break button. And here I'm going to say, I'll click on the Analyze tab, go down here, and it offers me the option to run code analysis on the solution or run code analysis on only photo browser. I'll click that. Oh, do you want to stop debugging? Yes, I do. So I'll click that. This takes a while to run. So let me describe what's going on. We built the photo viewer application, right? There were no errors, there were no warnings. It compiled, it linked, and it started to run. But there was a latent bug in there. And we only discovered that bug at runtime when we tried to execute the program. Well, that's a nuisance, because and this is something that we all live with every day. We can build an application, it builds cleanly, but there's bugs inside. And how do we find them? Well, if you want to find all of them, you need to write enough tests that execute all the paths through that code, which, due to the explosion in permutations of paths, is a long job, right? That will keep you fully employed for many years, right? So this is worrying, that it takes so much effort to ensure there are no bugs left in the program before you ship it out to customers. And really, it would be nice if the tools and the compiler and the rest of the tool chain would give us some help to discover these bugs before they went out. So what I've done here is asked the compiler, under these clicks that I did previously, to go and analyze the code. And it's still analyzing. If you focus on there where it says in the left-hand margin building, I'll just expand that again. In a second or two, hopefully, that will start to fill out. What we've asked the compiler to do there is be careful, be paranoid. Look at the code and try and figure out if there's any potential bugs in this code. I know that the first time around you said, yeah, it looks good. But be extra paranoid, be extra careful. That takes a lot more processing, which is why it takes longer to run through this analysis. Oh, good. So looking down there, you can see that we've asked it to be extra careful, and it's found lots of things to tell us about. So zero terminate, let me blow this down again. Zero termination, missing lock, memory something, and let me see, it's maybe still going. No, it seems to have decided that's all the possible errors that might be in our code. In the search box, there's search box everywhere in the next release of Visual Studio. I can do things like filter on memory, for example. So there's an interesting one there. Let me click in there, and it expands to give me diagnostics. And it also goes to the corresponding line on which the error was found. So if we look at this one, I'll blow that up, 150. It's telling us here that character buffer index is not initialized on line 124. And that's true, right? Character buffer index is just declared as int. I've not made it equal to 0 or 59 or 42. So that itself, that's no problem yet. It might be a mistake. You might have intended to initialize it, but so far it's benign, right? It won't break the program. But the next one here, yeah, this will break the program. Okay, this is going to be a loop that runs from something to a value less than 4 and sets custom state, an array, at the index given by character buffer index equal to A, right? That's going to blow up on the very first iteration of that loop because character buffer index, it's a local variable, so it in fact will contain any garbage left over in memory from the previous user of that space on the stack. That's a big problem. And rather than wait until runtime and 1,000 tests to find that issue, we've found it statically by asking the compiler to be more careful. Let me just go back and kill off that search and go down to another one. Dereferencing a null pointer. Well, this is a silly routine that's been made up specially to illustrate the point. Int I equals 0, that's good. We've initialized it. If putter, which is a variable defined somewhere up above inside this same class, if it's equal to null, right, then increment I, cool. If some Boolean variable is true, then I equals star putter. That's going to be bad. You can tell it's going to be bad. It's going to try and dereference a null pointer. Not a good thing to do. And again, we found it, or could find it, by dynamic testing, but it's so much better that the compiler directs us to the code to help us fix it before that happens. Looking under here, it gives me the option of doing stuff. One of the things that I can do is, not for this, but for a less serious error, I might say, well, that's a very fine warning that you've given me, but I'm not interested in this particular case. Remember, you want to have your code so clean that when you run this again, there will be no warnings. You will have somehow or other fixed all the warnings so they go away. One way of fixing is to say, I shall suppress that message. And if I select here and say suppress message in source, it will inject a pragma warning with the right number, 6011, to make that warning not pop up the next time that I compile, the next time I analyze the code. That's not a good one to choose, okay? But it's to show the principle that if you've got warnings, for example, uninitialized char buffer index, you know, the first one, it's benign, it's not fatal. So you may choose to skip that warning. Any questions at that point? Yes?
Most of the errors that we can see are not from the code itself, but from other files included by the code.
Yes.
And it's very bad because the real errors are hidden inside of it. Are you planning to do something about it?
Yes, good question. So the question is, most of these warnings and errors are ours, Microsoft, from runtime libraries. We'll be fixing these before that ships. This is a build from around September, which was even before a beta drop. So this software is, what would be the best word? Evolving or nascent, right? So we'll be fixing that, yes. Okay. Again, upstairs on the analyze, we've showed you what the compiler can do to help you find bugs that are in the software already. Across here, there's some more options under architecture, one of which is generate a dependency graph. So I can ask for a dependency graph for the solution, which will show me all the namespaces and all the images, all the binaries, and how they are related by calls from one to the other. Rather than show you that by building it, I'll skip back to the slides and run quickly past the demo that I've already done with the Photoshop dog. And show you this picture here. Now you may wonder, why did I not run this one live? Because I had intended to. Last Thursday evening, it started crashing on me. This is early software, right? So the demo started crashing on me. So I went home Thursday night really concerned that just about to fly out to Europe to do presentations, suddenly my demo would not work. So I tried again and again, eventually got it to run cleanly, as it had been doing perfectly the day before, and made some screenshots. So if I run that architecture analysis, here it gives me a picture of what's going on. Ignore the one called Bing Library. So it shows me photo browser and then some external binaries that it calls. I can expand any of them, so I've expanded here the photobrowser.exe, and it now shows me the namespaces with calls that go between. So for example, the global namespace has functions and classes in there that call down to the graphics, and vice versa. Okay. The vice versa, I guess, is okay, but it should cause you to pause if you're starting to learn this new application and say, well, was that a good and sensible design? Often it is, but it gives you a bigger picture and insight into how this application has been structured. Likewise, I can expand, let's say in this case, the graphics box, and find all the classes and the intercalls between them. So this tool gives me a technique whereby I can investigate the architecture of the application without having to read every single line of code and build up that mental picture inside my head, which is what we all had to do, several years ago. I'll skip back now to the application and show another architecture diagram, which is, in this case, specific to C++, where I ask for an analysis of the include files. Yes, question? In that case, no. I think PTR that I checked earlier that we were looking at, I think it occurs further up that same source module, that same compiland, and therefore would end up in the same binary. So it doesn't show that particular link. It's usually call hierarchy. Oh. Okay, so the question, if in the previous example we had the putter, the PTR variable, where was it actually defined? You can just hover on there and click F12 or right-click and choose Go to Definition. That will take you to where it was defined, and it was further up that file, yes. Oh, good, it's run. So this was an analysis that is run on the header files, the .h files, and it comes up with a picture. I'll get rid of that one. Comes up with this picture. Blow up a bit more. That shows me the interrelationship between all the CPP files and .h header files, and what includes what else. So if I just blow that up, we can see a picture here that has graphics controller.cpp it includes gridmanager.h, it includes graphics controller.h, which includes that, etc. Just going across the way. Also includes manager event handle, etc. You may next want to work your way through this, just figuring out what each H file actually does. It's handy in that case to be able to say, well, I've dealt with that one, so I want to colour it. So I'll categorize that as red, done, okay? So you can do graphics on that display and use it for documentation if you need to do paper documentation of what the application's about. It's also got a neat feature, well I think it's neat, that if the diagram isn't quite how you like, you can pick up a node and drag it. And the links are kind of like on springs with magnets repelling each other. So that allows you to manipulate the diagram to make it more in the form that you want for your documentation before printing it off or saving. The use for this sort of thing, or circular references in H files. This allows you a way to investigate and find it, refactor and fix.
Why don't you hide stdifix.h by default? Because it's a spaghetti and we know that we don't care about this file.
It's a good question. I'm not sure whether there's an option to do that in this release or whether it will be worked on. It's a good point. It just creates noise in that diagram. You're right.
The capability to hide is not.
Yeah, that.
You got just to use this, the delete option. And then
Oh, I see it on the node.
Removed,
Yeah.
and you have
Yeah.
a graph.
Yeah.
Easier to read.
Right. Yeah. Because at the moment it's telling us nothing useful. Again, if I hover over there, it gives me more information on the tooltip about each node. Yes? That I'm not an expert on this particular part of Visual Studio. I don't know. I believe so. They've been working on it, but I don't know the specific improvements since this build. Okay. Let's go.
What
Sorry?
version of Visual Studio got these tools?
So,
Do we need to have a ultimate version, or is it working with professional version? Visual
Good.
Express version?
good question. I don't know. Does anyone happen to know?
Architecture Explorer is only for ultimate version, and it was free, but now it's if you are not an SDN member subscriber, you can't have the last version. It sounds strange.
Yes, I only understand the
Audio
features.
tools and visualization features, blah blah blah. Maybe it's now labeled like this.
Okay, so it sounds like it's become ultimate, I'm afraid. So let me now go back to...
Still another question.
Yep.
Some other IDE have some tools for working with header files to clean up the headers. For example, you can detect that we include something and we don't need it.
Oh.
Or we don't include something, but we would need it on portable code because it's in all cases it's included implicitly, but by another file that
Yes.
you include.
Yes.
But in general, it's not guaranteed to be that way.
Right.
So there are some tools that in that direction. Do you have
Uh,
any plans to try
yeah.
this kind of tool?
So again, a good question. The last one in particular, where a particular compilation works fine, but it's because a header file that you included drags another file, other headers that you actually required. So it works by accident, as it were. In terms of whether we have tools or plans to do that detection automatically, I'm not sure. Don't know if Tarek knows. No, don't know, I'm afraid. We don't.
Some tools at Google that do that. I've heard of some tools for Eclipse that do that. So
These are certainly good suggestions. They would be valuable, especially for C++ development, because we have large code bases and your bound include hierarchy is traditionally very, very deep. Helping optimize that can also speed up builds in some way.
Okay, I'll go on to the next topic, which is unit testing and code coverage. So we're now reached there in the agenda. So this is the last section. I'll just mention in passing the static code analysis, which I showed earlier. It's very like lint. I've made as a memo to myself there. The old lint tool for C and C++ from years and years ago that you ran as a separate tool, it did this sort of thing as well, but without the graphics support. Okay, I'll break out of here and go back to Visual Studio. I shall close this solution Don't save changes. And open up another. So I'll go here, open project or solution, and I've got one here called calculator and calculator.sln. On the left-hand side, I have the window for Solution Explorer. I'll expand that. And you can see here that we've got a solution with, it's actually got 3 projects in it. Calculator service, hard to see, calculator service, and unit test 2, which I'll come to later. The calculator is the code that runs the GUI. The calculator service is the one which you might call the business logic, although in this particular case the logic is very simple. And the unit test, we'll get there in a second. So let me just go back down, and in here we'll go to 150%. And we'll start off, as usual, with a build of the solution. There's a small solution that runs quite fast. 3 succeeded, 0 failed, 0 up to date, 0 skipped, we're good. So let's just run this to see what it does. Debug, start debugging. Oh, it's a calculator. So 1, 2, 3, plus 4, 5, 6. When I first used this, I noticed the buttons are the wrong way round. They run from right to left. I don't know why. Equals. So that's all that the calculator does, right? It's very simple. And if I go to the calculator service function, which is here, and I'll just expand that some so you can see it. It's a simple class called calc service. It's got an empty constructor, an empty destructor, and then it's got the actual routines that correspond to the buttons on the calculator that I press. So there's one for addition, subtraction, and division, a little bit more complicated, multiplication, and calculating the power function. So what I'd like to do now is write some unit tests to make sure that this is correct. So in order to do that, I would go to the calculator solution, right-click, go down and say add a new project. Under new project, I'd go to Visual C++, the test category, and then I want to do a native unit test project, and I'd go ahead and click OK. Now, in this case, I'll press cancel because I've built one previously to save a little bit of time. It's called Unit Test 2, and here's what you get inside Unit Test 2. This is generated automatically by a wizard, and there's not much inside. But it's the start of building our own unit tests. So there we are. A couple of includes. The CP unit test.h is just a bunch of helper macros and functions. I'm going to use that namespace to avoid some typing. Inside this unit, inside the namespace unit test 2, I have a test class something. In the public section, I've got a test method called test method 1. It's in fact macros, yes. Okay, so that's a starter. So what do I actually want to do? Well, let's write a unit test for the add function. Okay, so what I'll do first is go up here and drag across a code snippet which includes the calculator service.h file so that I've got the functions I require. Down here I'll start typing with test method, and let's call it add test. Inside here, I want to do, well, I want a calc service, first of all. one of these, and I'll call it C. So that's the instance of the little calculator class that does the computations for me. I'll have an int A equal to, let's say, 3. I'll have an int B equal to 5. I'll have an int expected, let's call it, equal to, well, we're testing the add function, so it should be equal to A plus B. And I'll have an int actual, which is equal to C a dot, it's the add function, the one that we're testing, A comma B. Now next, I want to check the actual equals expected, okay? And for that, again, I'll go up the top and drag across. And here, no. I shall include another H file that we'll get to in a second. So going back down here, what I want to do is say assert colon colon r equal. It gives me a range of useful functions. R equal is the one that we want, and we want to say that the actual is actually equal to the expected. Right? And that's me done with a unit test for add. It's been slow and painful, and we've only achieved checking 3 plus 5 is true. But let's go and see what we do as the next step. And that would be to go to the window on the left, which shows the unit test explorer. We'll go back up here to a build and say build solution, please. Okay. On the left-hand side, I'll just expand that. On the left-hand side, we've got add test, the one that we just wrote. We had this test method one dummy thing that we'll ignore. So we're showing all. Let's just run and see what happens. There we go. Passed tests showing 2 out of 2. It took 0 milliseconds, which is what you would reckon. I mean, the clock speed on the chip is running at about a gigahertz, right? So it's a lot less than a millisecond to complete the whole thing. So we've done our first test. Well, that's fine. How do we add more tests? Or let's first think, what else can we do within this framework? Well, one of the things we can do is add attributes. And again, these are done using macros. Yes, question? Yeah, so you can show the results as coming out on a log file, but in terms of what the actual answer was, the 3 plus 5 being 8, no, the code that I've written there only checks that the two are equal, that actual equals expected. We could add more code to display the actual result that was found, but I haven't done in the example. It's just C++, so you can add any code that you want. So here we can add some things like the test owner, myself, the test priority, 1. We can do other stuff, like, for example, let me see if I've got the right one here. I've added there an attribute that says test ignore, right? So let me just run this and show what it does. Again, we go to build the solution. So we're good. Show all tests. Run all. And down the bottom, we can see that it says there, I'll expand. Down the bottom there it says, 1 test skipped, 1 passed. The one that passed was the dummy. So it skipped this. So what use is that? Can anyone think of, do you have situations where you've bumped into where that would be useful? Okay, so the one...
When a text actually fails, we want to focus on
Yes.
for debugging.
Right. So the situation that I can think of commonly is where you find that there's a bug in one part of the application, and you want to disable that test for the moment because it's spoiling all the other tests. So you would disable it for the moment until the bug is fixed, and then tomorrow when the dev has fixed it, you re-enable that test. So it allows the rest of the work to continue rather than block on everything. What other stuff can you do? Well, I shan't go into the gory details of this.
In C#, all the test methods are already written inside this class.
Yeah.
Do the same for C++ or not?
What we have at the moment is fairly basic in that you author the tests yourself. So let me go down here and I'll drag across some more tests. Here's one that, again, is very simple, and it's the one that tests for divide by 0. Okay? In this case, what we want to do is force an exception. So we can't use assert 2 results are equal. We'll have to check that an exception is thrown, and that's how we do it. Assert expect exception. The type of the exception is calc service divide by 0. And the action that you take, it's a lambda again, as anyone that was at the session just before lunch knows about. It's a C++11 feature that enables us to write functions that have no names. Okay? And in this case, all I'm doing is return c.divide a by b, where b is 0. This will force an exception, and we can catch it here in the test. Sorry?
Why mutable?
Oh, right. So the flip answer would be to say that it doesn't work if you don't have mutable in there. As to what's going on, it's about the way that lambdas are expressed within C++, where they're actually, what would you say, syntactic sugar for a functor class. Right? When you look at what's going on there, it needs to be mutable, but I'll probably take that offline and get back to you. Okay. When I first wrote it, I missed out mutable and it failed. It would not let me do it. I'll drag in a couple of other tests. There's one there. This is a divide test for a regular division. There's another test that tests the power function. I've got 2 of them, pow test 1, pow test 2. Anyway, let's go and just build that solution. It's running quite fast. And it's worked. It's always good when a demo works. Across here, let me see. I'll try running all. They all pass. So we've got a collection of tests and all of them pass. So the next question you want to answer is, well, have I tested all paths of my code? That's the thing that matters, the code coverage. Okay? In a large program, I could ask folks, testers here, what do you have? Do you have aims in your projects for the amount of code coverage you aim for to say, yeah, we've tested this adequately and it's okay to go ship? Like, yeah? I was wondering, so what sort of numbers? Like 60% code coverage is good, or 80%, or? Yeah, it's a difficult question to answer, and the closer you get up into the 90%, the harder you have to work to drive the code down all the separate paths. In this case here, it's a very simple example. It's contrived. But we have a button there on the left-hand side called Analyze Code Coverage, and I'll do that now. And what this will do is, this option was available before, but you had to do special runs to instrument the binary. In this case, it will do it automatically. I hope. Yeah, there we go. And down the bottom now, there's an extra report that gives me code coverage. I'll click it reports upon itself, but also the calculator service.dll, and I'll expand there and expand again, and find out that if I look at pow in particular, that's the one that calculates the power of x to the y, then I've not covered one block, which is 10%, but I have covered 9 blocks. So do folks know what a block is, a basic block? It's, if you look at any piece of code, there's sections of the code which are just one statement after another. You just execute them. So if you start on the first one, you execute all of the statements afterwards until you come to a branch in the control flow, which can be a test, like an if, or a loop. These are not basic blocks. There, you start a new basic block. So a basic block, as defined here, is just a sequence of instructions that always starts and executes from start to finish. Okay. So this one here, the pow function only has a total of 10 blocks. And I thought, when I looked at test pow1 and test pow2, that I'd covered all cases. So there I've done pow of A and B, so 7 to the power 4, that's good. And here I've done 7 to the power 0, that's good. But what's actually going on? So let's just click on here. I'll wind that window down a bit. And if I look here, in pow, it's got lines of 2 different colours. The blue ones are lines that I have covered in the test case. And the red ones are lines that I have not. And you notice this has been written so that there's a tweak in this code so that I take the power of A to the B by 2 and afterwards multiply an extra time if B was not even. And that line there I have missed in my tests. So instead of just doing tests that did 7 to the 4th and 7 to the 0, I need to do 7 to the odd number, like 7 to the 5, before I could say I've done 100% code coverage on that routine. Okay, so that is code coverage. It's a very trivial example, but it gives you a notion of, for a big and realistic program, that you can write unit tests and then easily get a view graphically of the lines of code that have been covered and those lines that have not, and therefore help to define extra test cases that manage to reach down the paths that you want to cover. Remember, if you ship your code to your customer with less than 100% code coverage, you are shipping code that has never been executed in a test environment, which is a little scary. Let me pop down that and return to the slides. Yes?
We are already using other frameworks to make unit tests.
Uh-huh.
Is it possible to integrate those frameworks into this UI?
So that I'm not sure.
Boost test or
Right.
CP unit or any kind.
Right. That I'm not sure. I'm not sure. Again, they're still working on this, so I'm not sure how far it has evolved from what I'm demonstrating there. Okay. Okay. Just about to go into question and answer. Here's some related content on ALM. So any of these links will give you more information. I guess I'll mention the guy there in that blog is called Brian Harry. He's now, I think he's a technical fellow at Microsoft. He's incredibly clever. And he's the guy that designed and led all of the ALM and TFS software. I have 2 adverts. First of all, for usability studies, we have a team which is normally based over in the US. They're coming over to Europe in May and looking for volunteers to take part in usability studies. That's where they give you some example tasks to do and observe how you get on as you work your way through using Visual Studio, and they use that feedback to redesign the product and make it better. So it's a chance for you to directly influence what the product looks like next time around. If you're interested, just go to that web link. And one last advert, which is on behalf of Microsoft France. And I shall leave you to skim through that, since your French is a lot better than mine. Okay, thank you. Any questions, ALM?